Anong dili man naman kita? Okay, so I think you can now see my screen. So our next topic will be about steam power plant. We're done with wait ha. I-fix na ako niya ko ang recording. Okay. So we're done with the diesel power plant and gas turbine plant. So we're now moving on to steam power plant. So there are four different cycles used in steam power plant, no? And the most basic one or the widely used cycle is the basic, which is the Rankine cycle. Okay, so it is the ideal cycle used as the standard of comparison for steam power plants. So this is the simple schematic diagram of a Rankine cycle, which has a pump, boiler, turbine, and condenser. Also here is the TS diagram of a Rankine cycle as well as the processes. Okay, so let's start with process 1 to 2. Okay, so process 1 to 2 is an isentropic expansion in the turbine. Okay, so if you look at here in the schematic, so from the boiler, which is responsible for heating water to generate steam. So ang magawas diri nga steam is a superheated steam, no? So it's high pressure, high temperature steam. Makita po nato sa TS diagram, no? At this point 1, which is in the superheated region. Okay? So musud siya sa turbine. So turbine produces work by expanding steam at high pressure and temperature. Okay? So syempre steam enters the turbine, which causes the blades to spin, no, to doing mechanical work. Diba? And that mechanical work will now be used to, which will be converted to mga electrical energy, no? So, musod siya, superheated steam, unya kay pag gigamit man yung energy, no, to do mechanical work sa turbine. So therefore, mugawa siya sa turbine nga wet steam na. Okay? Review sa data, no? So this is the saturation curve. So this is the subcooled region. Murag sakto subcooled region, and this is the superheated region, kanang wala na siya sa saturated, no, diba? This curve is the saturated curve, saturated liquid and the saturated vapor. Okay, so going back, so mo na pagawas niya sa turbine, so expand namang steam, no, so nagamit ng iyang energy, so enthalpy drops. So, ang steam will be wet steam na. So, makita po nato diri sa TS diagram, nga naa na siya diri sa wet vapor region, no? Kaning na nasa sulod sa curve or down sa curve. Okay? Then, process 2 to 3 is a constant pressure rejection of the heat in the condenser. Okay, so musod siya sa condenser, or ang steam musod sa condenser as a wet steam. No, so as steam, I mean as condenser, is responsible for cooling and condensants are condensing back into water, no, sa steam. So mugawas siya sa condenser as is saturated liquid. Okay, so makita po nato diri, no, nahimo na siyang saturated liquid. Di ba? Nisud siya sa condenser as a wet steam, no? Then the steam is cooled and condensed back into water. So mao nang mugawas po siya nga uh, saturated liquid. Okay, na siya sa point 3, that is a saturated liquid. Then process 3 to 4 is an adiabatic pumping, or also isentropic compression. No, so there is a pump. I-compress niya ang water, causing slight increase lang sa temperature. No, so that is from 3 to 4. So mugawa siya sa pump as a subcooled liquid. No, so mao na ni ang naa sa boiler. No, kaning subcooled liquid. Okay, so mao na pud to siya painiton, di ba? Like man by burning fossil fuel, no. Okay, and then process 4 to 1, which is a constant pressure addition of heat in the boiler. Okay, so mauna by burning, for example, by burning fossil fuel, no, initon ang tubig diri, which is a subcooled liquid, no. Then magawas na po na siya nga superheated steam. Okay, so that is the Rankine cycle. Okay, so dapat diri pa lang sa Rankine is ma-familiarize na nato siya og maayo. Okay, all the remaining cycles used in power plant are all improvements, no, from the Rankine cycle. Okay. So for the analysis of Rankine cycle, so heat added in the boiler, which is QA, so that is H1, no, H1 minus H4. Okay, so kung naay mass given, then multiplied by mass. So mass, or M, is the mass flow rate of steam, which is in kilogram per second. For the heat rejected in the condenser, or QR, okay, that is H2 minus H3. Kaya di ba, gikan man ni siya from boiler, gawa siya H1, musud siya sa turbine. Di ba? Turbine. So, nisod man na siya diri na H1. Okay. Nisod siya sa condenser as H2, no, which is a wet steam. H2, so mo ng H2 minus H3. Okay? H2 minus H3. So basic ang thinking na to, no, may mo bang out minus in. So depende na siya, no. Kaya parehas aning sa QA, that is H1 minus H4. Diba? And then for the heat rejected, ang nisod, no, minus sa nigawas. So H2 minus H3. For the turbine work, that is H1 siya, nisod, no, nigawas siya sa H2. Okay, H1 minus H2. That is the turbine work. If change in kinetic energy is given, okay, that is H1 minus H2, which is the QA. H1 minus H2 is the turbine work plus the the change in kinetic energy, or kinetic energy at point 1 minus kinetic energy at point 2. Now that is if there is a change in kinetic energy. For the pump work by energy balance, that is, so pwede na siyang exact pump work or approximate pump work. So depende, no, kung unsay given sa problem, So nai in terms of enthalpy and also nai in terms of pressure. So for the exact pump work, that is H4 minus H3. Okay, this is for the pump work. So kani siya. Okay? So H3 kay gikan man ni siya sa condenser, no? Okay, gikan na siya sa H2. So H3, H4. Okay, so H4 minus H3. For the approximate pump work in terms of pressure, that is volume times the pressure at point 4 minus pressure at point 3. Or kung na ay mass, multiplied by mass. Okay. This one, I know we have actual turbine work that is equal to the pump turbine efficiency times the turbine work. For the net cycle work, that is turbine work minus pump work. Okay, so tanaw natin diri no. We have turbine work minus pump work. So mao nang ato ang work net. Okay. Then we have, or turbine work equals to H1 minus H2. So wala ni siya kaning pump work lagi hapon ni kay depends man no if it's exact pump work or approximate pump work. For the actual pump work, that is a, a pump work divided by the pump efficiency. That is for the actual pump work. For the thermal efficiency, that is work net over QA, where work net is equal to H1 minus H2, where it is the turbine work minus the pump work divided by the QA, H1 minus H3. Oh, QA. QA is H1 minus H4. No, anong H3 man eh. H1 minus H3. So this should be H1 minus QA is equal minus pump work. Okay. So for the thermal efficiency, no, work net over QA, where work net is equal to turbine work minus pump work divided by QA. Okay. So H1 minus H3. Hold on. No? Ano man yung kuan man siya? H1 minus H3 minus pump work. Nga QA is equal to H1 minus H4. Diri dabig. Okay, so kani siya no, dapat si kuan ra ni siya kay QA man, work net over QA, so QA is equal to H1 minus H4. Our work net is equal to QA minus QR over QA. No? So H1 minus H4 na siguro ni siya dapat. Okay. For the steam rate, that is equal to 3,600 divided by the work net. Okay. So next we have reheat cycle. Okay. So the efficiency of the plant sometimes can be increased by withdrawing the steam from the turbine after it has partially expanded. and piping the steam back to the steam generator for reheating. So for the reheat cycle, our key here is the reheat, no? Meaning na siya'y reheater. And this reheat cycle also has the effect of reducing the moisture content of the steam in the turbine, limiting the amount of moisture to 10 or 12%. So this is important because water can cause increased turbine blade corrosion. Okay, so kaning sa reheat cycle, aside from there is a reheater, no, para mas musaka pagid ang iyahang energy. Oo. This also has the effect of reducing the moisture content. So, importante ning ma-reduce ang moisture content kay mao man na siya makadaot, no, or makakorrode sa turbine blade. So, syempre, kung corroded ang turbine blade, dili na gid na siya or mamubo gid ang iyang efficiency, di ba? So this is important because water can cause increased turbine blade corrosion. Okay, so the process 1 to 2 is partial isentropic expansion in the turbine. Sa Rankine cycle, automatic, it's a complete, no? Usara ka expansion, no, ang nahitabo sa turbine. Okay? But for this reheat cycle, na siya giingon of first is a partial isentropic expansion. Partial, so process 1 to 2. So mo as a superheated steam, na-verify po nato siya diri nga it's a superheated steam. So inigsud niya sa turbine, kato siya nga steam is or will be partially expanded in the turbine. No? So bisan partial pa lang na siya. Meaning kung partial, wala pa na nahurot ang iyahang energy. No? Nga pwede ma-extract sa steam. But although it's still partial, gahatag na gihapon ni siya or it's already mechanical work, no, to produce electrical energy. Okay? Then pagawas niya, so process 1 to 2, partial expansion. Process 2 to 3, so reheater. No? So reheater meaning, kung tanawan na to diri, no, at point 2, it's still vapor. No? Almost naana siya sa saturated vapor. Meaning, taas-taas gihapon ang iyahang kanang energy content ba, no? Dili pagid ingon nga pareha sa Rankine nga after it has been completely expanded in the turbine, muubos na gid tong iyahang, mahimo na gid siyang wet steam. No? Diri sa reheat, kay partially pa man siya, wala ba gid siya na fully expanded. Then i-reheat 2, so maunang na ay kuan pa, no, superheated steam pa. I mean saturated vapor or steam. So niagi siya reheater. Ang result is nisaka na pud ang iyahang enthalpy, no? Or nisaka na pud ang iyahang energy content ani niya. Okay? So 2 to 3 is a constant pressure re-superheating in the reheater. Okay, so 2 to 3 reheating, causing the enthalpy to increase, no? So, syempre, kung taas og enthalpy, so mas taas ang energy na pwede ma-extract from that steam, no? So, 3 to 4 is a complete isentropic expansion. So, inigsud niya balik sa turbine, kaning 3, mo na to, mag-complete isentropic expansion na sa turbine. Okay? So the same, mugawas from 3 to 4, mugawas na po siya diri as a wet steam. No? Wet steam. So syempre, no, na-extract naman ang energy from that steam. So, mubaba gid siya. Okay? So musud siya diri as wet steam sa condenser, then cooling it back or condensing it back to water. Then process 4 to 5 is a constant pressure rejection of heat in the condenser. So mugawas siya sa condenser as is saturated liquid. No? Then that saturated liquid Process 5 to 6 is an adiabatic pumping. Adiabatic pumping, so the water will be pumped back to the boiler. Okay, so na dere ang point sa boiler. Okay, sa point 6. Okay, so yeah, that's it for the 6 to 1 is a constant pressure addition of heat in the boiler. So mauni ang sa reheat cycle. Okay, so tungod sa reheating process, no, ma-avoid daw niya ang excessive moisture formation na may makaingon sa blade corrosion. Okay? So aside from increasing its efficiency, no, kasi syempre from point 1, no, then after superheating at point 3 mas nidako, mas nitaas ang iyang enthalpy, no, at point 3 after superheating. So obviously mo increase po ang iyang efficiency, diba? And besides that, ma-decrease po niya ang content. So sa diri, no, be extracted, no, there is a turbine. Okay, that's it for the reheat cycle. Ano pa the analysis, no? For the QA, that is H1 minus H6. For the heat rejected in the condenser, that is H4. Mali ni, no? This is H4 ni kay nanggikan man ni siya. So H1 magawa sa boiler, masud sa turbine, magawa sa turbine H2. Ano dili pa di ay? Naday siya superheating. So this is H4 minus H5. Dili na siya H3. Kay nadungagan man ang iyahang process. No? So kani siya nga part. Ay, hold on. No? For the heat added, for the heat added, that is H1 minus H6. Okay, kani siya. Plus H3 minus H2. So na H3 minus H2, it's because of the resuperheating. Okay, so kani siyang H2. Mura man ni siya okay kan sa so just sa boil turbine. Murag na superheater diri H2. Then H3. Okay. So ayo lang mo confuse aning ato ang illustration diri ba nga naay ni gawas nga H2 ni son nga H3. Okay? So H3 kay mao man ni ang steam nga ni gawas after superheating. Okay? So H1 minus H6 plus H3 minus H2. For the heat rejected in the condenser, that is H4 minus H5. Okay, so H4 dili na ni H2 kay na may laing process which is the 2 to 3. For the turbine work, that is, okay, so sa turbine work na naman siya katuning nisod no gikan sa boiler for partial expansion. Okay, mo ni siya ang partially expanded gawas siya. Then nibalik naman pud siya kay giri superheat man siya. So nisod siya as H3 minus H4 na pod, ni gawas na pod siya as H4. Okay, so that is the turbine work. Sa Rankine is only the H1 minus H2. Kaya may laing nisod, no? Or walay laing expansion na hitabo. But for this reheat, duha man ang expansion. Partial expansion and complete expansion. For the pump work, so for the exact, that is equal to H6 minus H5. Okay. For the approximate in terms of pressure, that is volume times P6 minus P5. For the net cycle work, that is turbine work minus pump work, where turbine is equal to H1 minus H2 plus H3 minus H4 minus the pump work, exact or approximate. For the thermal efficiency, that is work net of QA. Steam rate, the same, so 8,600 divided by the workload. Okay, any question for reheat? So remember, reheat is na lang siya reheater. No, so na siya partial. Then after partial expansion, musod siya sa, or mo-undergo siya superheating. Then magawa siya superheated steam na pod. Then another expansion, which is the complete expansion. Moving on to regenerative cycle. So cycle efficiency can be increased by bleeding a fraction of steam from the turbine and using the steam for regenerative heating of the feed water. Okay? For reheat cycle, ang na-add dito siguro nga component is the reheater. Right? For the regenerative cycle, na ay na-add nga feed water heater. So it can be an open heater or closed heater. Okay, so this steam may be fed either to an open heater in which the bled steam comes into direct contact with the feed water to be heated, or to a closed heater that is a shell and tube type heat exchanger. But commonly used, I think, is the open heater. Okay, so let's see for the process 1 to 2. Okay. So process 1 to 2, the same, no? Gawa siya sa boiler as a superheated steam. Then, mo undergo siya og partial isentropic expansion in the turbine. Ito isa, lambat. Okay. So, partial. So, mao ni siya, no? Process 1 to 2. Then, process 2 to 6 is a constant pressure rejection of heat in the heater. Okay. Rejection of heat in the heater. So, ang gingon mo niya diri, cycle efficiency can be increased by bleeding a fraction of steam. Okay? So, mga tag-bleeding a fraction of steam, meaning nikuha ni siya og part sa steam, no? Para muadto dito sa heater. So, the purpose is murag i-preheat niya ba, no? Ang feed water heater. No? So, kay partial pa man, no, partial expansion pang process 1 to 2, meaning taas maghihapon og energy content ang steam nga mugawa sa turbine, which is kaning 2. Okay? Kung atong i-verify sa TS diagram, no, naagihapon siya sa superheated region. No? So, taas-taas pagid siya og energy content. So, kana siya nga steam is, or ang iyang steam ana, is used to preheat the feed water heater. Okay? Kaning feed water, mura po niya siya i-pump dito sa boiler. Okay? So, preheat siya, no? So, constant pressure rejection of heat in the heater. Kay kaning tubig so dire is, kung tanawa nato si condition niya, 5.5. Oh, see, this is a subcooled, no? Ang musod diri sa ang sud diri sa feed water heater is subcooled liquid, no? So kani siyang gikan kani siyang 2 nga musod or steam nga musod diri sa feed water heater, iyang i-preheat ang subcooled liquid. Mao nang mga mugawa siya, no, at 0.6 is already a saturated liquid. So unsa man po'y murag kuan ana sa tawag aning advantage or benefit, no? Ang benefit ani niya, ang heat or ang heat energy needed to turn water into steam, no, diri sa boiler is dili ningon ana ka dako. Kumbaga murag ma-reduce, no? Kay kung tan-awon nato diri sa Rancain, ang musud Rancain. Rancain. Okay, ang musod diri sa rankine is subcooled liquid. No, sorry. Ang musod diri sa boiler is subcooled liquid. Now, sa ikumpara nato sa subcooled o saturated liquid, no, kung i-turn nimo into steam, no, the difference in the heat energy needed is mas gamay gito ang sa saturated liquid na daan. No, kumpara nimo sa subcooled. So murag mao'y advantage isa diri sa regenerative cycle. Kay murag ang purpose aning i-preheat niya ang feed water is para ang heat energy needed to steam that liquid or to turn that liquid into steam is dili na kay ngana kadako. Okay? Ma-verify man po nato diri sa ato ang TS diagram, no? So mo gawas siya sa feed water heater nga 6 saturated liquid. Okay? Then we have next is 2 to 3. So 2 to 3, okay. So kung ang muso diri is M, okay, which is the mass of the steam, no? Onya kay bleeding a fraction of steam. So kani siya kaning 2 to 6 part lang ani sa M. So that is sama na M1. Ito na to M1, no? Kay mao man ni siya ang part ni siya sa M, okay? M. So pasabot katong mass of steam used for complete expansion will be unsa naman M minus M1. Okay, this is for complete expansion, no? Na nasabdan na, nasundan ra. Hello? Hello? Nasundan?
Yes, ma'am.
Okay. Sabay pa dyan ako, no? Okay, so yeah, so siya nga M, then part of it used to preheat the feed water, which is the M1. So M minus M1 ang for complete expansion. Okay? So mugawa siya diri wet steam. So siya sa condenser, then mugawa siya nga saturated liquid. Okay? 4 to 5. Constant pressure rejection of heat in the condenser, then 4 to 5 adiabatic pumping in the first pump. Okay, for regenerative cycle, nanay duha ka pump, no? So, inyong timan-an nga for regenerative cycle, na siya nadugang nga pump o na ay feed water heater. Okay? Kaya pwede ramang good po og dili ginato memorize on tanan kaning TS or processes, pwede ra pud og diri ta mag-analyze sa iyahang schematic. Okay? So, saan naman ta? So 5 to 6, constant pressure addition of heat in the heater, no, which is kaning constant pressure heat addition of heat in the heater. Yes, 5 to 6. Okay. Then 6 to 7. Okay, mao na ni ang pump back to or water is pumped back to the boiler. Okay. So for the analysis, okay, so heat added is equal to, sorry, for the heat added is equal to MH minus MH1 minus MH7. Okay. Okay, so M, no, dili maglibog sa mass, no, sa mass gamiton. Okay. So dapat nasabtan nato diri kung lisod siya nga M na ay M1 nga nigawas diri. Unya ang gi-used for complete expansion is M minus M1. Pasabot all throughout the process, one na ginang mugawas ana, no? So heat rejected in the condenser is M minus M1, no? So kay matong giingon nga ang gigamit nga steam is or the steam used is M minus M1 naman lang. Okay, times the H3 minus H4. For the turbine work, okay, turbine work is M times H1 minus H2. Okay, so na H1 for partial expansion, H2. Then for complete expansion, ang gigamit is M minus M1 times H2 minus H3. For the pump work, no? Exact total pump work is pump work 1 plus pump work 2, where pump work 1 is, okay, so bantay mo no, kaning pump work 1, sa may pump work 1. Work, yeah, is M minus M1. So this is the pump work 1, and then the pump work 2. Pump work 1 daw is M minus M1. Of course, kay mao man na iniagi diri no. M minus M1 there is a condenser. So that is M minus M1 times H4, H5 minus H4. Okay, plus M times H7 minus 6. Okay, this is our pump 2. So M. Ganong M. M times H7 minus H6. Okay, this one, no? H7 minus H6. So that is M. For the approximate total pump work 1 plus pump work 2, so in terms of pressure, no? So the same na siya. For the net cycle work, that is work, turbine work minus pump work, or QA minus QR. For the thermal efficiency, work net over QA. Steam rate is equal to 3,600 divided by work net. For the mass extracted of steam, M1, so this is how to get the M1, no? So usually given man sa problem ang mass of steam, no, or the M jud. Okay? So let's say we have an open heater, feed water open heater. So this is musod dira ang M1H2. Okay, M1H2 kay mao man ni ang gikan sa turbine, no? Okay, di ba naman diri ang H1. Then H1 to H2 is a partial expansion. So mo nang na H2 nga mo gawas din ha. So mo nang M1 H2 niya. M1 sad ni siya kay mao man ni ang bled steam, no, or fraction of steam used for preheating. Then kani siya nga part diri, this is from the pump, no? Okay. So mo man ni ang gikan sa pump 1. No? Okay. So mao man ni ang kaning M minus M1 mao man ni ang i-process for complete expansion. Diba? Mao man na ang musod siya. Mao man ang musod diri. So times H5. Okay? Then mugawas diri M. Okay, anong M1? Kasi syempre, M1 plus M minus M1 is M. Gets ninyo? No? So, katong ni gawa sa open heater is the combination of extracted steam, no? O katong extracted steam, ang steam plus steam minus the bled steam. Okay, so by heat balance in the regenerative heater, so M1 plus M1H2 plus M minus M1H5 equals to MH6. So makuha na nimo ang extracted steam, which is equal to M times H6 minus H5 over H2 minus H5. Okay, so this is a common unknown no sa power plant nga mga problems. Kay naay mga problems nga dili tibuok system. Mura bag ang problem is nagtuyok lang sa open heater, no, or feed water heater na apoy mga problem nga nagtuyok lang sa turbine, no, ana ba? Dili gyud siya ingon nga tibuok system gyud na pay tibuok, no. Pero common rasad ang ingon ani, no, feed water heater nga mga problem. Okay. So moving on to reheat regenerative, no, the last one. So the reheat and regenerative cycles are combined to further improve the overall thermal efficiency and further reduce the moisture content of steam to minimize corrosion. So this is a combination of reheat and regenerative cycle, meaning na ay reheat process na per regenerative process during a cycle. So let's say for process 1 to 2, expansion. Okay. So gawas siya diri as a preheated steam, no, kaning M. Then undergo siya o partial expansion. Okay. So sa naa diri ang sa man regenerative, no, nga regenerative like nga kuan ba process. Regenerative. I don't know. Sa man Okay. Diri ang murag regenerative. Okay, so partial expansion, so kung tanawa na to at point 2, it's still a high pressure, high temperature steam lang gihapon. No? Although, ni-decrease siya gamay, pero it's still in the superheated region. Okay, so taas pa siya ang energy content. So this is used to preheat the feed water heater, or the feed water, sorry. Then, next is process 2 to 3, intermediate. Okay. It's an intermediate isentropic expansion in the turbine. Okay. So, part of the steam, no? Okay, M1, mao ni siya ang nidong sa feed water. Mao ni siya ang blood steam, no, used to preheat the feed water. Then, process 2 to 3, which is M minus M1, sorry, adara, no? M minus M1, mao to siya gi-used for intermediate expansion, meaning wala ba gyud siya gi-fully expand, no? Naa pa gihapoy nahimilin, no? So, I mean, wala pa fully na extract ang energy from the steam ba. Okay, so imo nang giingon niya intermediate expansion pa lang. Okay? So paggawas niya diri sa point 3, no? So ni-undergo siya og intermediate expansion, ni gawas siya sa point 3, niagi siya og superheating, excuse me. Hold on. Thank you. Salamat. Salamat. Okay, sorry. Ala, wala man na mao ako ang recording. Ay, ano man eh. Oh, no. Record magod ko kay kanang wala ko nakaklase sa 4B ba kay wala jud ko ka-connect kanina. Yeah, wa day gihapon na mao. So, balik tanong. So, 2 to 3. So, inigawas niya at point 3. Moagi siya og reheater. So, nairi sa preheating. Sumusod na po siya diri balik sa turbine, no? Nga, nisaka na po ang iyahang energy. So, as you can see from point 1, this is the partial expansion. So, after the expansion, decrease gamay ang iyahang energy, and then, ni-undergo po doog intermediate expansion, the more it reduces. Tapos, pagawa sa po niya, niagay siya sa superheating, nisaka na po ang iyahang energy, no? Sa point 4. Okay, so kaning point 4 mo na ni ang complete expansion, no? Complete expansion, isentropic expansion in the turbine. Then, okay. So, back to the same process. Mugawas na po siya diri as wet steam. Then, saturated liquid. Then, to the feed water heater is a subcooled liquid. Then, after preheating, magawas na po siya sa heater as is saturated liquid. No? Then, pump back to the kuan, boiler. Okay? So, nana lang. Okay? So, for the heat added in the boiler, that is H1 minus H9. No? MH1 minus MH9. Then, for the heat rejected in the condenser, that is M minus M1. No? Kaya usually, pangitaon ra ba ni siya ang value, no? Kaning M minus M1 or the M1. So that is H5 minus H6. Okay? So, di na mo ma-confuse, no? Kung sa nga mga, pwede rin ginagdili memorize ning H1 minus H9, H5 minus H6. Ang importante nga malabel ninyo og sakto ang inyuhang schematic, no? Or ang inyuhang TS diagram. Bahala pa man gud og magkabaylo-baylo na siya. As long as nga sakto ang labeling, sakto inikuha niyo sa formula. So, bisag kita ang labeling ninyo, nahimo ni siyang H3, no? Ya kani kay H4, no? Bahala pag nga yung labeling. Basta yung nag-ambot ninyo sa inyong formula is masakto po ninyo. No? So, mahimo po siya dapat nga H3 minus H4. Okay, so dili agad necessary nga i-memorize. Okay. Then, for turbine work, that is, so pila naman ni kabuok? 1, 2, 3. Okay. So, tulo na siya, no, ka-turbine work kay katulo man siya musod na ay partial expansion, intermediate expansion, and the complete expansion. Morning tulo. So, for the first expansion or partial expansion, that is M times H1 minus H2. Ang sunod is M minus M1, H2 minus H3. Then, M minus M1 lang gihapon, no? Kay maura man gihapon to ang nituyok for resuperheating. So that is H4 minus H5. Okay. For the pump work, exact total pump work is equal to pump work 1 plus pump work 2, where pump work 1, okay, pump work 1 is katong after the condenser, no? What pump work 1? Then, ang pump work 2 is after the feed water heater. Okay? That is in terms of pressure. For the approximate is equal to P9 minus P6. So, kato na ning lahos P9 kani dari kani nga point og kani nga point. So, kung given ra na sa problem, so diretsoon ra na siya. Then for the net cycle work, that is turbine work minus pump work, or QA minus QR. For the heat added in the reheater, or QRH, okay, so reheater, zaman tong ibagikan man ni siya sa turbine, no? Turbine. That is after intermediate expansion, diba? This is after the intermediate expansion kay H1. Na. So, M minus M1. Ay, bali. So, muna siya ang gikan sa turbine. Okay. Ay, nanagkadimao. Muna siya ang gikan sa turbine. Uy, ano naman ano lang kanang sa drawing, sa illustration na rin, no? Okay, basta kay kaning H3, mauni siya ang gikan sa turbine. Okay. Haluin siguro ni. Ang nisod is H3. Ni gawas is H4. Di ba? H4 minus H3. Okay. So M minus M1 times H4 minus H3. Okay. Kaya ang H3, mao man ni siyang musod sa resuperheating process. H3. So H4 minus H3. So sakto ang formula, no? Sa ato ang schematic. For the total heat added, Q total is equal to QA plus QRH. Okay. So na QRH, kaya na may heat added, no? Dinha sa feed water. Wait lang. Oo, kaya na siya resuperheating process. Okay. Then sa boiler, yeah, resuperheating. Okay. For the thermal efficiency, that is work net over QA. For the steam rate, 3,600 divided by work net. So careful mo, no? 2,000. So make sure that your work net is inconsistent formula. I mean unit, nga kilojoule per kilogram. For the mass of extracted steam, or M1, no, so mo ni siyang extracted steam, M1. So by heat balance in the regenerative heater, so mo man ni ang M1, no, ang fraction of steam nga nisod for preheating. Ya mao po ning M1 minus M1 mao ni siya ang ni-undergo sa complete expansion. So mugawas gikan after sa turbine, or after complete expansion is mao gani siya M minus M1. So M1 H2 plus M minus M1 H7 is equal to M H8. Therefore, M1 is equal to M times H8 minus H7 divided by H2 minus H7. So for all steam cycles, the actual efficiencies are, for the actual turbine work, that is turbine efficiency times the turbine work. For the actual pump work, that is pump work divided by the pump efficiency. Okay, so those are the 4 cycles used in the steam power plant. Do you have any questions? Wala ra. Okay. So, next time na ko, no, or next meeting na ko muhatag, ugma. Okay? So, ugma na ko muhatag og mga sample problems ani. Okay, so please review on your spare time, no, kani nga mga cycles. Runtime, the basic one. The reheat cycle, which has a reheater. Then the regenerative cycle, which is there is a fraction of steam used to preheat the feed water. Then the reheat regenerative cycle. Okay? So let me check the attendance kung wala rin question. Nabay makahapit. Basta na yun makahapit ninyo karon, no? Nanay inyo ang quiz 1. Or attendance. March 16. Okay. Heno.
Present, ma'am.
Apale. Present. Baliwis.
Present, ma'am.
Bildoro,
Present, ma'am.
Biniga,
Present, ma'am.
Beru,
Present, ma'am.
Biloy,
Present, ma'am.
Bolotaulo,
Present, ma'am.
Botero,
Present, ma'am.
Boyonas,
Present, ma'am.
Canlas,
Present ka na last, ma'am.
Creencia,
Present, Crenshaw, ma'am.
Cocharo,
Present, ma'am.
Felicita,
Present, ma'am.
Galia,
Present, ma'am.
Gonzalos,
Yung nga po, ma'am. Present, ma'am.
Hordesta,
Present, ma'am.
Ikas,
Present, ma'am.
Holo,
Present, ma'am.
Igaspe,
Present, ma'am.
Lumod,
Present, ma'am.
Marimon,
Present, ma'am.
Mission,
Present, ma'am.
Omega,
Present, ma'am.
Raimonde,
Present, Monday, ma'am.
Remolado,
Present, ma'am.
Salapit,
Present, ma'am.
Tagakanaw,
Present, ma'am.
Tero,
Present, ma'am.
Tumamak.
Present, ma'am.
Okay. So,